Are you ready? Everybody look at the camera, smile. 1, 2, 3.
On May 30th, 2007, Iowa State President Gregory Joffre joined several researchers from the Iowa State College of Engineering in dedicating the new W.M. Keck Laboratory for High-Throughput Atom-Scale Analysis. The ceremony was the highlight of a day-long symposium on atom probe tomography, sponsored by Iowa State's Institute for Combinatorial Discovery and the Combinatorial Sciences and Materials Informatics Collaboratory, or COSMIC, a National Science Foundation International Materials Institute led by Iowa State Professor of Materials Science and Engineering, Krishna Rajan.
The purpose is to bring together some of the leading groups in material science who work on atom probe or are interested in atom probe tomography, and to also show them our capabilities and to establish our reputation in this field.
One of those capabilities is the star of the new Keck Lab, a $1.6 million local electrode atom probe, or LEAP, microscope, one of only 4 such instruments in U.S. academic institutions. The LEAP is capable of gathering data from materials samples at a scale previously unheard of, producing 3D images of materials at the level of their individual atoms. Yet that unprecedented level of detail brings challenges of its own.
The interesting thing about the atom probe is not only its own unique capability as a microscope, but it's a microscope that has the capacity to generate massive volumes of data, and the interpretation of that data is as critical as the ability to acquire the data. And that in turn requires skills and infrastructure which most places don't have.
A big part of that infrastructure lies in computation that can analyze these massive data sets as fast as the atom probe can produce them. In 2006, Iowa State acquired an IBM Blue Gene L computer, at the time one of the 10 most powerful supercomputers in U.S. academic institutions. With 2,048 processors and 11 trillion bytes of data storage, SciBlue's teraflop system is capable of performing up to 5.7 trillion calculations per second. Srinivasa Luru, a professor of electrical and computer engineering at Iowa State and an expert in massively parallel computation, is working with Rajan and other members of the Institute for Combinatorial Discovery to link the Blue Gene's analytical power to the atom probe's prodigious data output.
I was very interested, especially with the arrival of the atom probe microscope, because as a supercomputing researcher, we are always looking for large-scale problems. So essentially, any cutting-edge problems in science and engineering today deal with very large-scale data, and to analyze that you need supercomputers. And in order to do meaningful research with supercomputers, we're always looking for huge problems like this.
As impressive as this combination is, however, what makes Iowa State truly unique in the search for new materials capabilities is the third item in the investigator's toolkit, the C6 chamber of Iowa State's Virtual Reality Applications Center. Recipient of a $5 million upgrade this spring, the C6 can now project resolutions up to 100 million pixels, making it by far the leading facility of its kind in the world and the ideal environment for visualizing the three-dimensional images generated by the atom probe and Blue Gene L. Here, you can literally stand inside a tiny material sample and scrutinize its nanoscale structure atom by atom. Attendees at last spring's symposium, which included Australian collaborators using the state-of-the-art remote conferencing facilities of Iowa State's Engineering Distance Education Group, had the opportunity to inspect Iowa State's cutting-edge facilities for generating, analyzing, and imaging the coming revolution in materials, and to discuss the virtually unlimited potential that the synergy of these three tools offer investigators in the materials community.
This is a unique opportunity for Iowa State to distinguish itself, as it's one of the few institutions that has both the infrastructure and the expertise for connecting atom probe microscopy and tomography to the ability to do scientific visualization, as well as the ability to do computation, which requires supercomputing. And all these three abilities to converge at one time is very, very unusual and gives us an opportunity that most institutions don't have.
For the Engineering News Network, this is Dennis Smith.